Welcome to Naradar Academy. In this video, we are going to discuss about bilinear transformation and some elementary transformations. Okay. First one is bilinear transformation. See, bilinear transformation is a mapping defined on the complex plane, extended complex plane. Okay. So before going to bilinear transformation, let's recall about real functions. That is when you define a function in the real numbers. See, we used to represent the value in the domain along the x-axis. That is, along x-axis we take the domain values, and the values of the codomain are taken in the y-axis. That is, this is x-axis, and the values of the function f of x are defined along y-axis, because here this is the domain and this is the range, so we can represent it like this. But when you talk about complex numbers, we are talking about plane. So if you take the value of the domain in this plane, the value of the codomain is taken in the another plane, and it is denoted by W plane. So Z plane means domain and W plane means what? Codomain. Okay. So when we define a function t from Z plane to W plane, we have to represent like this. Here the real and imaginary parts are x and y, that is z equal to x plus iy. This is the domain, and in the range or in the codomain we define it as w plane. W equal to what? U plus iv, where u is the real part and v is the imaginary part. Simply here z equal to x plus iy, its image is u plus iv. So wherever you see w, it denotes the image of z. And what is this w? U plus iv, where u is the real part and v is the imaginary part. So here we define w equal to t of z equal to az plus b by cz plus d, where ad minus bc is not equal to 0. This is called bilinear transformation. This maps the extended complex plane onto itself. This is a bijection. Bijection means what? For every point on the z plane, we can find a unique point, unique image in the w plane. Okay, and for every point in the w plane, we can find a unique pre-image in the z plane. Okay, so this is called what? Bijection. Bijection means it is both 1 and onto. 1 means for every point in the z plane, you can find a unique image in the w plane. Onto means what? For every point in the w plane, you can find a unique pre-image in the z plane. So this is called bijection. So our bilinear transformation is a bijection. Okay, so here I have already told you that this is a mapping defined on the extended complex plane. Extended complex plane means what? C with infinity. Okay, so what about infinity? What is the image of infinity and pre-image of infinity? So both the planes include infinity. So what is the image and what is the pre-image? The image is t of infinity is equal to a by c, and the pre-image t of minus d by c is equal to infinity. Okay, so this defines a bijection on the extended complex plane. And so whenever you have a mapping and it is a bijection, its inverse definitely exists. Okay, so the inverse of this bilinear transformation is given by t inverse of w equal to minus dw plus b by cw minus a. So this is the definition of bilinear transformation. Okay, right. Next one is, we are going to see what is a cross ratio. See, cross ratio is a value defined on 4 distinct complex numbers. Alright, in the extended complex plane, not only for the finite complex numbers, for infinity also we can define. For extended complex plane, we define the cross ratio as, this is the notation for cross ratio. If you write 4 complex numbers within bracket like this, it represents the cross ratio. And the definition is z1 minus z3 into z2 minus z4 in the numerator, divided by z1 minus z4 into z2 minus z3. This value of cross ratio plays an important role in the bilinear transformation. So remember this formula, z1 minus z3 into z2 minus z4 by z1 minus z4 into z2 minus z3. What is special about this bilinear transformation for this cross ratio? It preserves cross ratio. That is, every bilinear transformation preserves cross ratio. This important point only we are going to use in the problems for identifying the bilinear transformation. Okay, what does it mean? See, if you take 4 distinct points in the z plane, let me take z1, z2, z3, z4. Take 4 distinct points here. Okay, find out the cross ratio. Okay, keep it here. And now all these 4 points will have a unique image here, no? So let them be W1, W2, W3, W4. So here I am having 4 images here. Find out the cross ratio for these points also. These two cross ratios will be same. Okay, understand? That is, when you take 4 points in the Z plane and their respective images in the W plane, their cross ratio will be equal. That is why we say the bilinear transformation preserves cross ratio. Okay, next one is fixed points. Fixed points mean, see, if I take a point Z, for example, if I take 0, if 0 is mapped to 0, then 0 is called a fixed point. If 1 is mapped to 1, it is called a fixed point. If 2 plus I is mapped to 2 plus I, it is also called fixed point. That is, whenever a point has the same number as its image, then that point is called what? Fixed point. Okay, so for a given bilinear transformation, W equal to AZ plus B by CZ plus D, the fixed points are obtained by solving this equation, that is Z equal to AZ plus B by CZ plus D. Why do we write like this? Because what is Z? T of Z, no? What we say, T of Z equal to Z, that is the point is same as its image. So we put Z equal to AZ plus B by CZ plus D. So by solving this equation, we will get the fixed points of the given bilinear transformation. So based on the fixed points of the bilinear transformation, we classify them. Okay, if only infinity is the only fixed point, infinity is the only fixed point, that bilinear transformation must be translation. I will explain what is translation here. Okay, so infinity is the only fixed point means what? That is called translation. If my bilinear transformation has only one finite fixed point, not infinity, only one finite fixed point, it is said to be parabolic. Okay, if my bilinear transformation has two fixed points that are finite, both are finite. In that case, you write the bilinear transformation in this form: W minus alpha by W minus beta equal to K into Z minus alpha by Z minus beta. What are these alpha and beta? They are fixed points. That is, alpha is mapped to alpha and beta is mapped to beta. Okay, if you write like this, then depending on the value of K, we classify the bilinear transformation. If K is a real number, the bilinear transformation is said to be hyperbolic. If modulus of K equal to 1, then the bilinear transformation is said to be elliptic. Okay, so these are the some interesting facts about bilinear transformation. Next, we are going to see some of the basic elementary transformation. These are some special cases of bilinear transformation, we can say. The first one is translation. Here I have given 4 such types. The first one is translation. Translation means it will be looking like W equal to Z plus B. Just what I am doing, Z plus B. So what is the transformation made here? Just what it doing is simply translates the image. That means if you have a square or a circle or a straight line in the Z plane, there in the W plane also it will be the same image. But how it works there, it just translates from one position to another position without any change in the shape, without any change in the size, without any change in the orientation. It just moves from one particular, see, if I am having a line like this, just this line is moved somehow like this without changing its size, shape, orientation. It just moves, so it translates. This is the role of this transformation. Okay, so what is the first one? Translation. The mapping will look like this: W equal to Z plus B. It just translates the image without any change in the size, shape or orientation. Okay, what are the fixed points? Infinity is the only fixed point. Okay, so next one. So whenever we are dealing with elementary transformation, we used to discuss about what happens to straight lines and circles under this particular transformation. So already I told you, no, this transformation just translates, move from one place to another place without changing size, shape and orientation. So straight lines are mapped into straight lines and circles are mapped into circles. That's all. So we have seen what is a translation. Next one is rotation. Rotation means the definition is given by W equal to AZ, where this modulus of A equal to 1. This is this condition is must for rotation. For rotation, what it is doing, it rotates. That is, suppose if my domain is having r theta, my image will be what? R comma theta plus alpha. For example, if I am having a line like this in the Z plane, then in the W plane, it will be rotated through some angle either increased to through some angle theta plus alpha or theta minus alpha. Can you understand? This is my image in the, this is my diagram in the z plane. In the w plane, what it happens, it will be getting rotated to through some angle alpha. Okay, right? So here also there will be no change in the size, there will be no change in the shape, only the orientation is rotated. So how much angle it gets rotated, that is another question. You see here I have written a is it, no, this a argument of a, look at the argument of a, that angle is taken as alpha, that angle is changed here. Here 0 and infinity are fixed points. Okay, here also the circles are mapped into circles and the straight lines are mapped into straight lines. So what about rotation? Rotation preserves the shape, size and shape, it just changes the orientation is changed. So it rotates through some angle given by argument of a. 0 and infinity are the fixed points. Here also straight lines are mapped into straight lines and circles are mapped into circles. Next one is magnification or contraction. Magnification or contraction, this is also similar to rotation, but in rotation we take modulus a equal to 1, no, but here it is not like that. It is b is z, where b is a real number with b as positive. Okay, so both of them are looking like the same. So when the modulus of a is equal to 1, it is rotation only. When b is real number with a positive value, it is called magnification or contraction. And in specific, when will it magnifies your image and when will it contract your image? Magnifies means what? It extends, the length increases. Contraction means what? The length shrinks. Okay, so it magnifies for b greater than 1 and contracts for b less than 1. So what happens here? There will be no change in the shape, there is no change in the orientation, only the size either extended or contracted. Okay, magnified or contracted. So r comma theta will become b r comma theta. R denotes the magnitude, no, only the magnitude of the complex number changes, there is no change in the orientation. Whereas in the previous case magnitude remains the same, only the angle changed. Here magnitude changed and the angle remains the same. Here also 0 and infinity are the fixed points, and here also straight lines are mapped into straight lines and circles are mapped into circles. So we have seen 3. The final one is inversion. Inversion means w equal to 1 by z, or in polar coordinates we can write it as 1 by r into e power minus I theta. By looking at this you can understand it changes both the magnitude as well as the orientation. So it changes everything. Okay, so what is this inversion? Inversion is with respect to unit circle, because e power I theta will become e power minus I theta and r becomes 1 by r, no. So it represents inversion with respect to unit circle and reflection about real axis. That means points inside the unit circle will become points outside the unit circle and vice versa. Okay, here 1 and minus 1 are the fixed points. Here we cannot simply say circles and straight lines. So we will discuss what happens to circles and straight lines. See, this is the general equation of the circle. I have taken in the regular Cartesian coordinates form. A into x square plus y square plus bx plus cy plus d equal to 0. This is the general equation of a circle in Cartesian form. See, for this equation to represent a circle, x square and y square coefficient must be same. Okay, coefficient of x square and y square must be the same, and then no product terms should occur, xy term should not be there. Okay, then it represents a circle, right? So this is a circle equation, and this here constant d is there, no. If in any equation, if you have any constant that does not pass through the origin, if you have a constant, it does not pass through the origin. If there is no constant, it passes through the origin. Okay, so that is how we have to identify. So here this equation is mapped into this equation. What is the transformation here? Very big calculations are there. So this, if this is the domain and the range, in the range the image will be d into u square plus v square plus bu minus cv plus a equal to 0. You have to remember this equation. So image of this is this. So what happens? Circle not passing through the origin. Circle means what? This x square y square term should be present. Okay, so a is not equal to 0. Not passing through the origin means what? D is also not equal to 0. So if both a and d are not equal to 0, here also a and d are not equal to 0. So circle not passing through the origin is mapped to circle not passing through the origin. Next, circle passing through origin. Circle passing through origin means this constant is absent. D is 0. So D 0 means here what happens? This term will not be there. Only this term alone will be there. Okay. So circle passing through origin will map to here only this equation you are having no. Here no u square v square term. That means what? It represents a straight line. But A is not equal to 0 here. So it represents straight lines through origin. Okay. Next one. Straight line not passing through origin. Sorry, this is not passing through origin. Straight lines not passing through origin. Because here A is not equal to 0, no? So straight lines not passing through origin. Now, next let's take straight line not passing through origin. Straight line means this A should be 0. Then only it represents a straight line. Not through origin means D is not equal to 0. In that case, here D not equal to 0, no? So it represents a circle. Since A is 0, what happens? It represents through origin. So circle through origin. Next one, straight line through origin. Straight line means what? A is 0 and D is also 0. If both of them are 0, what happens? Again, you will be getting here both these terms absent. So you will be getting only this U and V term. So it is mapped to straight line through origin. So what I have discussed here is this A and D determines this equation. If A and D both are 0, it represents straight line passing through origin. Okay. If both are not equal to 0, it represents circle not passing through origin. By changing the conditions A equal to 0, D equal to 0 and take both are not equal to 0 and take one equal to 0, the other not equal to 0. By variating this A and D, okay, you will get different images. That is what I have written. Okay, right. So these are the specific cases for this inversion. Okay, that's all. So here in this video what we have discussed, bilinear transformation and some of the elementary transformations. Okay, I will do the problems based on these types in the next video. Okay, thank you.